This segment's going to look at epidemiology. We give the general concept of how do people influence plant disease epidemics. Plant disease epidemics are going to occur no matter what happens. The thing is, we have an ability to influence the way they occur, how problematic they become. In this, we need to define a few things. Number one, epidemiology is the progress of disease over time. What we're looking at is, rather than looking at just a snapshot when we're looking at infection or symptomology, we're looking at what was it like yesterday, what's it like today, what's it going to be like tomorrow. We can figure out over time what we've got. We still have the favorable environment, the susceptible host, the virulent pathogen, the interaction between these three parts that give us disease. In epidemiology, we add the factor of time. Time affects the environment. We see changes in climate, we see changes in daily temperatures, moisture, and everything else. That affects the environment. These changes affect the host. They also affect the pathogen. When we look at epidemiology, we've got to look at environment, host, pathogen, and what happens over time, how these things change from one day to the next in order to be able to deal with this particular part. What is an epidemic? An epidemic is an increase in disease above the normal that you would expect. There's always a background level of disease. We call that background level endemic. With an epidemic, you have an increase above that which you would normally expect. Epidemiology is the study of this. We study epidemics, we study how things change over time. When we deal with this, we go back and we talk about monocyclic pathogens. When you're dealing with a monocyclic pathogen, the most important part in this is going to be your primary inoculum. Your primary inoculum determines how bad your epidemic's going to be. If you've got a lot of primary inoculum, you've got a bad time. I saw a cornfield once where they had planted seed that was infected with smut fungus. Nothing germinated. The farmer said, "What do I do?" He was told to go back and replant. He came back in with pathogen-free seed. He got a normal crop out of it. It's a monocyclic pathogen. So when we deal with these, we have to look at things like primary inoculum. With a polycyclic pathogen, it's not necessarily the primary inoculum which makes the difference. Rather, you've got your secondary inoculum that comes around. You have to look at how long does it take for the secondary inoculum to be produced, how frequently it gets produced. The more frequently it is, then you get different problems. You can modify the way the disease occurs. We call that a rate of infection. If we look at something like wheat, this is primary inoculum. These are infected seeds. Primary inoculum makes a big difference on all diseases, but it especially makes a very big difference on a monocyclic disease. You always want to try and keep primary inoculum down. Here you've got coffee. This has coffee rust. Coffee rust is a polycyclic pathogen. Therefore, you're looking at rate of infection. How quickly does it go? How can we monitor that and interfere with it? This is a leaf spot on something like tomato. This is going to depend on how frequently the new inoculum is produced, how destructive that actually gets because of sheer numbers. When we deal with these, we often look at what we call a disease progress curve. We're always looking at a polycyclic pathogen. On a monocyclic pathogen, it all goes back to primary inoculum. If you can knock the primary inoculum down, you don't have a problem with the disease. On a polycyclic pathogen, we look at disease progress curves. This shows you a disease progress curve where no control measures are instituted. This basically means that the disease starts out and over time it goes up and it reaches a maximum. Rarely is that maximum 100% of the crop, but it might be. Your whole challenge here is to make sure that you get your crop formed, your production out of it before it reaches its maximum. This is what happens if you reduce primary inoculum. You reduce primary inoculum, the curve doesn't change. What you do is you buy more time because it takes longer for the primary inoculum to build up to a point where it's really going to be problematic. If you change the rate of infection, that means how many new lesions do I get out of each new inoculum that is formed. By doing that, what you can see is you slow down this curve. You make this curve more elongate. By making the curve more elongate, you get less disease over time. This last one shows you what happens if you decrease the primary inoculum and you reduce the rate of infection. You can see that this is real good because by the time our harvest is coming in, the disease hasn't reached its maximum yet. By doing that, we can now guarantee that we get a really good production. One of the ways we study this in plant pathology is to look at the area under the disease progress curve. There's a lot of mathematical equations that you can use to determine this, but the area under the progress curve really shows how things are going. This shows you the typical disease where you've got no intervention in it. You can see how it has a amount of progress in the bottom part. That's the amount of disease. It's an awful lot of disease. If you slow down the rate of infection, you get less disease. It also shows less area under the progress curve. As you have less area under the progress curve, it means your epidemic is going to be less severe. By changing parameters in here, you can drastically affect how problematic disease is. This is all looking at it from the perspective of the plant and disease progress. We're looking at plants and how do plants go out and deal with disease.